Hello there. Let's talk about how to create tags. In the original Ars Logic 5000 star page videos, uh, there are two separate topics on this subject. There are two separate videos, I should say. All right. One is create a tag. The other one is uh, create a alias tag. Because these two subjects are closely related, so I decided to put them into one video. Uh, then on the next video, I will demonstrate with the Studio 5000. All right. Uh, so let me first introduce some of the concept. All right. Also, you can see here, I have a uh, different term. All right. First time to talk about that. It's called the user memory. All right. So I call that user memory in contrast with the I call system memory. All right, within PLC, as you understand, it's just a special computer, right? Within computer, you have a memory. So you have part of a memory you, as a user, as a programmer, you cannot access to, right? That's called system memory. For example, let's say, for example, that if PLC need to keep track how long a certain program or task has been running, or maybe the configuration of the like Ethernet IP address, right? And also the system clock or something like that, right? So they have to have some memory to in order to maintain the system, or maybe called housekeeping, right? So that's part of memory you cannot access, but you do have a big chunk of memory that as a programmer you can decide how to use it. That's all what I call the user memory, right? So you may already understand some of the uh, memory I have been talking about, right? So first, with this memory, you can store data, right? With data, first type we already talked about so many times, right? The I/O, right? So the input output. Once you create those modules underneath I/O configuration, the I/O tag will be automatically created on the controller level. That's where uh, we have been talking about in the previous videos. So that's the first category. Then you have a second category called tags. All right, as a user, as a programmer, you can create tags by yourself, right? Because those I/O tags are generated automatically by the software, and you can create your own. And when you create tags, you have a choice, two location. One is called controller tags, and the other one is called program tags. All right, so I will talk about more details in the following slide. So this is one type of data. You store data, one type of memory, right? You store data. Other part of memory you may want use to store your actual program logic, your program code, right? So that's obvious, right? So, but I need to point out with Logic 5000 controller, they organize the program in three different levels, right? So that's the part we need to focus on for, within this video. Those three levels called task, program, and routine. So underneath the program controller, you can see here, you have a folder called tasks. Within the tasks, the first level you have called main tasks, right? So in the separate video, I'll talk about there are different type of tasks, right? So this icon you can see here, a folder with a circular arrow that represent continued tasks. So that means these type of tasks will will be running all the time once you power on PLC, right? There are also other at least two type of tasks, but I'll talk about that on different video. All right. So this is the first level task. And underneath task, you can create second level called program. Right. Within program, you will be able to create program tags or called local tags. Right. And specifically with the code, right? So that's a third level. Underneath program, you can create routine. All right, all the routines created within the program, there more than it could be more than one routine within underneath one program. One of them will be called main routine. All right, and also if you I should mention that within the task you can create more than one program, right? On this picture, I only show one program. Later on, you will see that you could create separate programs underneath main tasks. All right. So let's move on to the next slide. So talk about tag, right? Tag definition is a text-based name. Right. For area of the controller's memory, you can see here memory, right? User memory, where the data is being stored, right? So what do we mean by text-based, right? So if you think about the I/O tags, the software automatically generated, remember that? So like local, that's what we talk about on the video. Column, right? I forgot slot number one, column, something like that, right? There's a long list, long name on here. That's program generated, right? But this text based, right? So that means you have a choice. Right? Remember, we talk about the rules for the tag name. You can, as long as you follow those rules, you can create the tag name by yourself, right? So that's the freedom with the tag. When we talk about the tag, right? So there's three properties we need to be careful because you have to use them in the program a different way, depends on the properties. These three properties, at least over here. One is called type. The other one is called data type. They're different, right? One is called tag type, the other one data type. The number three property is tag scope. So the tag type, all right, basically talk about two different categories. One is called base. The other one called alias. That's what we're gonna talk about within this video. There are more than two types, right? There are other types. Again, that's beyond the scope of this video, right? You can, uh, if on my mind, it's the consume and other type of tag. All right. So maybe I'll talk about later on different videos. All right. So the base tag is the default. So basically, that's just what we define at the top, right? So you gave a name, you store a value. Then this value will be used later on in the logic. So that's a default. Then the other type called alias is just a special type. You use alias to represent another tag, right? So that's what does it mean, right? Alias, second name, another name, or nickname, right? So that's what we will continue to talk about. Give you an example. So second property is data type. That's a very basic type of the basic property with tag. Lots of people didn't pay attention on this, will make a mistake in the program because data type defines the type of data that a tag stores, such as bit, integer, and floating point, right? Because they are different. Bit, it's just either 0 or 1. Integer, you can have numbers, whole numbers. Floating point, you can have decimals, right? So definitely they are different, right? You may think in human uh, world they are the same. They all represent numbers, but in the computer they're different because they could be operated totally differently, right? So I'll again later following slide we'll talk about more. Right? For the scope, you have two categories, right? So I already mentioned that so many times: global or local, right? Controller or program tag. Right? All right, so uh, let's move on to the next one, more on the details. All right, remember these three properties. tag type, data type, and tag scope. So first, what is alias? Right, alias lets you to create a tag represent another one, right? So I already explain that, right? Both tags share the same value. When the value of one tag changes, the other one tag reflect the changes as well. So you may ask, what's that for, right? Why bother? Why do we need this, right? So you use alias in the following situations. One, when you program logic in advance of wiring diagram. So that means when you design the logic, when you design the program, you don't have the specific connections on the physical input output. You don't know, right? Because the hardware design probably in parallel with your software design, right? In parallel, right? So you cannot wait for the electrical uh, hardware design finish, then you start software. That's going to be too late, right? So take a longer time. So those company will try to do two things in parallel. So your logic can be designed in advance of the hardware diagram. Right? There's an example in the following slide. Also, that's alias. You can use that uh, to describe a I/O device more specifically, right? And also in other situation, you can use a simpler name to represent other complex name. For example, UDT, user-defined data type, a array. There's some other advanced topics. Uh, this it's something else I won't talk about in this video, right? Then let's look at what do I mean by these 2 points. All right. So over here, first, you program your logic by using the descriptive tag names. For example, over here, if you already have some programming experience with ladder logic, you understand this, right? This is typical 3-wire control, right? PB1, PB2, and motor. And then motor seal in PB2, right? So you can design this logic without any knowledge of the hardware configuration, without any uh, knowledge of how do we connect those PB1, PB2, right? You can just design it. You can even test it by using emulator or other methods to test your logic without connecting to the real device, right? But later, when the wiring diagram available, right, you can connect them. You can add the I/O module and convert the script tags to the alias. So now you can see here, right? The logic is the same, right? This is the exactly same logic as the one you had before. You just need to convert from this PB1 into this IO tag, right? So you can see here, this is IO tag. It's a Ethernet IO adapter and input and data or something like that, channel 1. This is channel 2, right? So that means this red, this is the descriptions from the tag editor. You can do that, right? So for example, you said, okay, this is the red normally close push button, right? In the program, we call PB1. We don't need to change that. We can just keep using the same name. We just need to assign this PB1 to this point to point to the real input. And this is another push button, right? Connect to the input. Then you have output, which is the motor starter coil, right? So you can use this to finish your ladder logic, right? So that's the purpose. So you don't have to wait to have all the hardware information in order to program your logic. You can go ahead, then use Alias to connect them. All right, so the over here, Alias is belong to the first property, right? Tag type, right? Either called base, that's a default, or alias. There are also other types we don't need to worry about now. All right. Second property is this, the uh, data type, right? Data type that I'm showing you over here in the Logic 5000 memory. Uh, which is a 32-bit processor, right? So the basic unit in the memory is 32 bits. That's why we call 32 bits computer processor. It counts from 0 to bit 31. So if you create a tag, which is the Boolean type, bool, right? Actually, you only use the lower bit number 0. And then all the other 31 bits is not used. It's kind of wasted, but because memory is become cheaper and cheaper, right? So uh, that's what the way they set up in Rockwell. Even before like RS Logic 500, they use totally different way to manage the memory, right? So they have to count every bit in the memory, because back that time the memory is very, very expensive. They want to take use even in the PLC 5, right? They have to count every bit, right? Because they're very expensive. Then if you use from bit 0 to bit 7, all 8 bits together, then you have the other data type called signed integer. So that can have a negative to positive, those range numbers. Again, whole numbers, right? So if you use the int, then that will use all the lower 16 bits. So obviously that has a wider range on the numbers, right? Then if you use all 32 bits, that'll be din, like double integer. So you may ask, if we can use all 32 bits, why don't we just use either bool or din, right? Why do we still need this, right? Those are reserved for some special type of the device. They also need to connect to PLC, right? Then they are not 32-bit system, right? For example, you have a barcode reader or scanner, something like that. When when those kind of device need to communicate with PLC, they don't have a 32 bits in their memory. So then you have to create corresponding tags in order to talk to those equipment, right? Then the other type, real, right? So if you use all 32 bits, then you use a special type of the memory arrangement. You can use that to represent the decimal number. For example, 3.14 pi, right? The value of pi, something like that, right? That beyond my knowledge. I don't even know how do they do that. They use a special type of the scientific notion or something like that, arrange those data in order to get the decimal point included in there, right? So you just need to know that very often we'll use either bool, double integer, or if we need a decimal points, we choose the real, right? Then there are also other different types. I mentioned a little bit before, you can even create your own user-defined data type, right? So over here, let's just list the structured data. It's called counter and timer, right? So they are structures, right? So we will talk about that when we discuss the instructions. They are closely related to instructions with the data, right? Okay, uh, let me just move on to next slide. So this is the third property called the uh, scope, right? Tag scope. So I believe you already heard so many times, you understand what do we mean by that, but I need to reinforce that again. So there are two different levels, right? So either controller level or the program level. On controller level, it's because has the whole uh, whole range, right? So it's like a file cabinet, right? So whatever you put into the controller level, it's a global, so everybody can see it, everybody can access it to it. So that's why the IO data has to be controller tag, right? So because no matter how many program, how many tasks, how many routines you have, they should be all be able to access to the input output, right? So that's why they're in global. There are also other data type. There are also other data if you want to share on the system level, right? So you create on there, but most of the time you will take advantage to use the local. That means you go into a task. It's like a drawer, and then going to the drawer, you have a different file folder called the. I don't know if the analogy here work well or not. So, like for example, you go into the file cabinet, you see that you have an organizer, right? So like a program. Then within this binder, you will have different files. That's main routine, other routines, subroutines, right? Each different files, right? And within this same binder or called program, they share the local data, right? So what's the purpose of this, right? So next slide, you can have a better understanding on this. So with tag scope, you can organize your tag um, in a very systematic way. All right, so let me illustrate here. So from this picture, you can see underneath the program organizer, you have a task, right? Then within the main task, you have two programs, program A, program B. You have two programs. So notice these two programs are in parallel. They're in identical level situation, right? So look at on the right hand side. So if you have controller tag, right, follow this on here, you have two tags called tag underscore one, tag underscore two. So all the program can access to these two tags. So program A can see tag one, tag two. Program B can also see tag one, tag two. But within the program, if you create tags, they belong to the local. They are private. So if you create tag 4, tag 5, you can see here within program A, then within program B, you can also create tag 4, tag 5. Notice they are the same name, but they don't exchange. There are no interrelation between those two tags because they belong to different local scope. So in this way, if one person work on program A, right, the other person, the other programmer work on the program B, they can freely create their own tags. So without worrying about if there's a conflict with multiple program, right? So later on, when both program finish, they can put together as one project, they will work, right? So because all the tags you create locally, they don't interfere each other. That's guaranteed, right? But in the contrast, right? So if you need program A and program B need some handshake, they need to work together, need to exchange data, then they can take advantage on the control level. So for example, tag one, tag two, there'll be handshake, right? Whenever program A change tag one, the program B will see that. When uh, program B, if make change on tag two and vice versa, right? Program A will see that. So in this way, you can have a very good way to organize the your data, right? So this is just a introduction. In the next video, I will talk, will do the demonstration with the creations. All right, all right. See you next video.